So let's start with section 5.5, exponential and logarithm manual. The first example, check how they're gonna ask you. We're gonna fill this table. We have initial invest, we have annual rate of interest, time to the double, and amount after 10 years. So this is the tricky example with this one. We need to find the time to double, and we need to find the annual rate, the amount after 10 years. So the first thing they're telling you here, assuming continuously compound interest. That's mean on the first example, they're telling you you're going to use this formula, A equal P E R T. P is the initial invest, A is the future amount, E R is the rate, and T is the time. They're telling you look to the first one. So the first thing I'm gonna look just here. I have initial invest, I have annual rate. Annual rate, that's mean R is equal 5.4, which is equal 5.4 divided by 100. And then this one is going to be equal 0.054. And I have time. They didn't tell you the time. So now here is the information I have. I have P equal 2000, which is the invest. And I have rate. And the first thing they ask you, time to double. That means they ask you to find the time. Time to double the invest. That means the future is going to be 2 double this one, which is equal 4,000. So now I have the future because they're telling you we need to find the time to double. That means double the invest. That means our future amount is going to be 4,000 equal. The invest is 2,000. E, the rate is 0.054 and times T. So the first thing I'm telling you, when you look at these examples, you're gonna look, here's the first part. We have the initial, we have the annual rate. We need to find the time to double what? To double our invest. That means our A is going to be 4,000. So here is our A. So we're gonna use this information to find our rate. So to find the time. Now here is the initial, the future amount. Here is our initial, the invest. Here is the rate, and here is the time. What I'm going to do, the first step, I'm going to divide by 2,000. Divide this one by 2,000. So cancel these. 4,000 divided by 2,000 is going to be 2 equal E to the 0.054, and here is the time T. So now I need to solve it for T. T is an exponent. The only way we can cancel the E and convert this one from the exponent to just a number, we're going to take ln to the both sides. Because we have a rule that says x equal y. That means ln x is going to be equal ln y. 1-to-1 property. So I have x equal, everything here is the y. So I can take ln to the both sides. That means ln to number 2 is going to be equal ln. Here is the E, 0.054, and here is the T. I'm going to cancel the ln with the E. The left on this side is going to be 0.054, and here is the T. In fact, it's just about just canceling. You're going to move this one by using the power property in the front. Ln times E is going to be equal 1. So it's going to be this one times 1 is going to be this one. But the easiest way, I'm just going to cancel these and write down this as a number. And here is the left side, which is ln to the 2. Then I'm going to find the value of t by dividing both sides by 0.054, and here is by 0.054. That's mean t is going to be equal, because you're going to cancel these, equal ln to number 2 divided by 0.054. That's mean our time is going to be equal. So let's check how much it's going to be. It's going to be ln. I think I have a calculator here, I can use it. It's going to be ln 2, close the parentheses, divided by 0.054. Is going to be 12.83. They ask you to round your answer to 2 decimal places. So our time is going to be 12.84. 12.84. So this is our time. This is the first part of this question. So we're going to type here 12.84. This is the first part. So now when the time equals 10 years, we need to find the future amount. We want to use exactly the same formula, which is A equal P E R times T. Time in this case equal 10. The invest exactly the same invest, which is 2,000. We need to find the future amount. That's mean A equal 2,000. E, the rate is 0.054 and the time is 10. So in this case, we're just going to plug in everything here. 2,000 e to the 0.054 times 10. The result is going to be 3,432.01 cents. That's mean our future amount is going to be 3,432.01 cents. Because there is a 3 here, so around this, so it's going to be 0, 1. So that's it for this example. So we're going to type here 3,432.01. Here we go, we got it right. So again, be careful, it's 2 parts. Every table here, it's 2 parts. You have to think how to find the first variable here, and then think about to find the second one. So it's really important to focus on these examples. Example 2, first of all. So we're going to do exactly the same thing, but let's check what we have. On example 2, they're telling you find the missing value, and the same thing. They're telling you it's continuously compound. That means the formula I'm going to use, A equal P E R T. Exactly the same formula. Now let's check what do we have. We have the initial invest. We have the P equal 200. And we have amount after 10 years. But let's check here. The first thing we need to find the annual rate of interest. That's when we need to find. And time to double. So here's our formula. The first thing I need to find the rate of interest. And by using the rate of interest, I can find time to the double. But I have A, which is the amount after 10 years. I have A equal 1005, and the time is equal 10 years. So let's check how we're going to use this information to find the rate. I can use all this information to find the rate. Then I'm going to go back and find the time to the double. So that's the important thing, because it's exactly the same rate. So I have invest, I have the future amount after 10 years. So I'm plugging all this information here. That's mean 1005 equal, the invest is 200. E, the rate, that's what we need to find. And the time is 10. So the only variable here is to find the rate. So let's go ahead and check how we're going to find the rate. Exactly the same steps. I need to keep this part by itself on this side. So I'm going to divide by 200. So divide both sides by 200. Cancel here. That means on this side is going to be r e to the r times t. On the other side is going to be, we have to divide. And be careful, do not round the numbers. Divide by 200. So it's going to be 5.025. So I'm going to type here 5.025. Now, next step, x equal y. By using one-to-one property, that means ln x is going to be equal ln y. So I'm going to take ln to the both sides. That means ln to the x, which is 5.025, equal ln e to the r times 10. Cancel this one with this one. So it's going to be r times 10. And on this side is going to be ln 5.025. Now, last step, we're going to divide both sides by 10. In this case, r is going to be equal ln 5.025 divided by 10. Let's check how much it's going to be. Ln to the 5.025, close the parentheses when you're dividing, divide by 10 is going to be 0.16144. And we have to round 2 decimal places. Yes. So our rate is going to be 0.1614. Let's keep it 1614. Okay, so this is our rate, but we need to write down the rate in a percentage. Now our rate is not in a percentage because always we have to write down the rate in a percentage. So what are we gonna do? Instead of dividing, we're gonna multiply. So we're gonna multiply this number by 100. So it's gonna be 16.14%. So we're gonna say the rate equal 100 times 0.164. So our rate is going to be 16.14%. So that's our rate. And that's what we're going to plug in here. The rate is going to be 16.14% because in the percentage. Next part of this example is we need to find the time to double. Time to double, it means your future amount is going to be double the initial, which is the invest. That means my future amount is going to be double to the invest, which is equal double to the 200, which is equal 400. So that's my future amount when it's double, but I need to find the time. I have the rate. That's mean A is going to be equal P-E-R-T. My goal is to find the time. So the future is going to be 400 equal 200 E. The rate, you're not gonna plug in this one as a rate. You're gonna plug in this amount as a rate, which is 0.1614 times the time t. We're gonna do exactly the same thing. We need to find the time. So I'm going to divide both sides by 200. Cancel here. That means 2 is going to be equal e to the power 0.1614 times t. Then I'm going to take ln to the both sides. Ln e 0.1614 t. That's mean you're gonna cancel these. So the left on this side is going to be ln to the 2 equal 0.1614 t. The last step, you need to find the time. So divide both sides by 0.1614. Cancel here. That means the time is going to be equal ln 2 divided by 0.1614. So it'll be 4.29. 2945. So it can be 4.29. That's it for this example. So we're gonna plug in here 4.29. So our example 2, here is the solution, is right. Let's go to example 3. Example 3, let's check what they ask us. They ask us to find the missing value continuously compound. So we need to find the initial, and here is the annual rate of interest. So I need to use this information. So I need to find this part first. I have the rate, and I have the amount after 10 years. So I'm going to use these three information to find the P. Then I'm going to find the time to double. So for example 3, we're going to use exactly the same formula, which is A equal P ERT. Now I'm going to look here. I need to find the initial invest. That means we need to find P. And what do we have? We have the annual rate. We have R equal 6.8. 6.8%, which is equal 6.8 divided by 100. So let's check how much is going to be. 6.8 divided by 100. So it's going to be 0. You're just going to add 0 here. 0.068. So this is our rate. And we have the A after 10 years. It's 1600. And the time equal 10. So I can use all this information. I have the amount after 10 years. I have the rate. I can find the initial invest. That's mean 1600 is going to be equal P and E. We have the rate, which is 0.068 times the time T is 10. I'm going to simplify it because I can multiply these two. So 1600 is going to be equal P E, multiply these two, so it's going to be 0.68. Now my goal is to find P. P is the variable, so I can divide both sides by e to the power. And divide this one by e to the 0.68. Cancel these. That's mean P is going to be equal. Here is going to be 1600 divided by e to the power 0.68. That's mean our invest is going to be, which is going to divide 1600, 1600 or 16,000? 16,000. Yes, I am saying 1600. Okay, 16,000 is going to be divided by the second fraction e to the power 0.68. So the result is going to be 8105, which is 8,105.87. So this is our invest. Now, the second part of this example, so we have the invest, which is 8,105.87. Now, our goal is to find the time to double. Time to double, it's mean double the invest. That's mean your future amount now is going to be double the invest, which is equal double. The invest is 8,105.87. So I'm going to multiply this one by 2. So it's going to be 16 to 11.74. So this is the double amount. We need to find the time. That means we're going to use the same formula, A equal P E R T. Your future amount now is going to be this one. Equal the initial, which is, here's the initial 8,105.87. E, the rate, which is 0.068, and the time here. Now divide these both sides by 8,105.87 and divide this one by 8,105.87. Cancel these. So this one is going to be 2, because here's this one is going to be divided by the initial equal 2. So here's going to be 2 equal e to the amount 0.068 t. Now we need to solve it for t. So what I'm going to do, take ln to the both sides. Ln to the 2 is going to be equal ln e 0.068 t. Cancel these. So in this case, going to be ln to the 2 is going to be equal 0.068 t. Now divide both sides by 0.068, 0.068. That means the time is going to be equal ln 2 divided by 0.068. So we're going to divide ln to the 2 divided by 0.068. It's going to be 10.19. 19. So we're going to type here 10.19. That's it for this example. So we got it right. Let's check example 4. Example 4 is look like example 2. No. Let's say it's look like example 1. Also no. Example 4. Let's work on this one. So let's work on example 4. We can do exactly the same thing. Let's check what do we have. So example 4, find the missing value. We have the initial invest is 5.5, but before that, I'm going to check it's continuously compound. So I'm going to use this formula, A equal P E R T. Let's check what do we have. We have the initial invest is 550. So our initial invest is 550. And we have time to double is 6.5 years. 6.5, which is equal. Let's convert this one to a proper fraction. So 2 times 6 is 12, plus 1 is going to be 13 over 2. 13 divided by 2 is going to be 6.5. So this one is going to be 6.5 years. So this is our time. That's the only information we have. We need to find the amount after 10 years, and we need to find the annual rate of interest. Time to the double is, here's the time to double the initial. To double the initial, that means your future amount when at this time, the time to double is 2 times the initial or the invest. It's going to be 2 times 550, which is equal 2 times 550, 1100. So this is our future at the time the double of the invest. That's mean A equal P E R T. The double amount equal the invest. E, the rate is, we need to find the rate, but the time is 6.5. So what I'm going to do, I'm going to divide both sides by 550. This is canceled. So here's going to be 2 equal E R times 6.5. Take the length of both sides. Cancel these. That's mean length to the 2 is going to be equal R times 6.5. Now the last step, we need to find how much is going to be R. So we're going to divide by 6.5. That means our rate is going to be equal ln 2 divided by 6.5. It's going to be 0.1066. And take this number. So this is the rate. With the percentage, so I'm going to multiply it by 100. That means going to be 10.66%. 66%. So this is our rate of interest. Now, next part of this example, first of all, we're going to type here 10.66. Now, our next part is to find the amount after 10 years. So now we need to find the future amount, and the time is 10 years. So what we're going to do, we're going to say A equal PERT. A equal, the invest is 550. E, the rate is 0.1066 times the time is T. That's mean our future is going to be, you're going to plug in everything here. So 550 e to the power 0.1066 times 10. So equal 1597.06. So that's the future after 10 years. So we have to plug in here 1597.06. So we got it right for example 4. You're going to do exactly the same thing with example 5. I'm just going to give you a hint. So do not focus on the annual rate. The first thing, how to find the initial invest. You have time to the double, and you have the amount after 10 years. So time to the double, you're going to use the time to double. That means your future amount is going to be double the invest. In this case, let me work on this one, because you're gonna get confused. How are you gonna work on this one? For example 5, we have the time equal time to the double equal 11 years. But it's telling me the time to double. That means our future amount is going to be double the invest. I'm going to plug in these in the formula, which is A equal P equal P, A equal PERT. The future is 2P, which is the double of the invest. That means here is going to be 2P equal PERT. Cancel the P from both sides, because you're going to divide both sides by P. That means the time is 11. So I'm going to plug in 11 here. Now the left is going to be 2 equal ER times 11. Take ln to the both sides. So ln to the 2 equal ln ER times 11. Cancel these. That's mean ln to the 2 is going to be R times 11. Now we need to find the R, so I'm going to divide both sides by 11. So R is going to be equal ln to the 2 divided by 11. So we're going to find the interest. Annual rate of interest is going to be ln to the 2 divided by 11. It's going to be 0. That means our rate is going to be 0.0630. Multiply this one by 100. So it's going to be, your rate is going to be 6.30%. So this is our rate of interest. Now, next step, we're going to find the time to double. So I'm talking about example 5, yes. So our rate is going to be 6.30. Now, how to find the initial amount? We're going to use the same formula, and we have the amount after 10 years. Now we have A equal 1900, and the time is 10, and we have the rate. I'm not going to use this rate, I'm going to use this one. So we're going to say A equal P ERT. A equal 1900 equal P, that's what we need to find, times E, the rate is 0.0630 times the time is T. Let's simplify this side. This side is E to the power 0.0630 times 10. So here on this side, D is going to be 1 point, or the easiest one, because sometimes you're going to do mistakes if you round this number. So my advice, you're going to divide both sides by E to the power 0.063. Let's multiply this one by 10. 630. Yeah, first of all, I have to multiply it. It's up to you the way how you're gonna find it. You're gonna simplify the whole sides here, but you have to write down the whole number. Like 1.877610579. Or you can divide both sides by everything here. It's going to be the same result. But do not round this number. Equal 1900. Now you're going to divide both sides by this really big number, 610579, and here is going to be 1.877610579. Cancel here. That means P is going to be equal 1900 divided by this number, and it's going to be equal, the initial is at 1011.92 cents. So this is our initial. So we're going to type here 1011.92 cents. Because with example 6, you're going to say, okay, but I don't have the initial, so I can double it. So you can assume that just your future amount is going to be to the initial. Plug in these here. Here is the future amount. This is your future amount, which is going to be double the initial. Then in this case, you're going to divide both sides by P. So that's why you're going to cancel P from both sides, the left here, and you're going to keep going the same process to find your rate of interest. Go ahead now, use the rate of interest, and you have the time and the amount after 10 years, you're going to find the initial. That's it for this example. So we got example 5, right? Let's go to example 6. The first thing, let's read example 6. So example 6, determine the principal P. So that's what we need to find. The principal P, that means the invest. Must be invest at rate equal 3.5%. That means our rate is going to be 3.5, which is equal 2 times 3, 6, and 1 is going to be 7/2, which is equal 3.5. 3.5%. That's mean equal 3.5 divided by 100. So it's going to be just going to add 0. It's going to be 0.035. So this is the rate of interest. Now let's keep going. If we need to find compound monthly. Compound monthly, that means they're telling you n equal to 12. And which formula we're going to use? We're going to use the formula. It says A equal P 1 plus R over N Tn. This is the second formula. If it's compound monthly, quarterly, semi, daily, you're going to use this formula. If it's compound continuously, you're going to use the other formula. So that 500,000 will be available in the retirement. That means this is the future amount, which is A equal 500,000 is going to be in the account after 15 years. So the time equal 15. So that's all this information. We need to find the principal P. That means the invest. So we're just going to plug in everything here. Here is the future, which is 500,000 equal. That's what we need to find. 1 plus the rate is 0.035 divided by the compound, which is 12 monthly. That means n equal to 12. Time is 15 times 12. So now we're going to look how we're going to simplify this one. So the first thing, what I'm going to do, I'm going to simplify everything here. I'm going to say 0.035 divided by 12 is going to be this number. This number add to the 1. So add 1. So we're going to get P 1.002916667. That's what we got. 15 times 12 is going to be 180. So this side, we already have this amount, and the other side is 500,000. Now let's simplify this one, which is this number to the power 180. So it's going to be here is P, and here is 1.689167696 equal 500. Then divide both sides by this number here to find the value of P by 1689, and keep going on this number, and here by 1.689 and keep going. That means it's going to be 500,000 divided by this number. It's going to be the initial P is going to be equal 296,003 and 0.77. That's me 1, 2, 3. So 269,003.77 cents. That's our initial amount. We have to invest this one. So our retirement is going to be 500,000. So we're going to type here The initial is going to be 296,003.77. So here is the wrong thing I did. So here on the calculator, you get 296,003.78, and there's a 3 here. So I don't have to round the number. So here is going to be just 78. 78. So I'm gonna put here 78. That's it for this example. Yes, we don't have to simplify it, round it. 7, 8. That's it for example 6. Let's do the same thing with example 7 and 8, but now with different type of examples. When they ask you half-life, this is really important examples. For example 7, find the missing value. For radioactive element, so check here, don't confuse yourself about this one. This is the element symbol. So we're not going to confuse ourselves here. Half-life years. Half-life years, that means the future is going to be half the initial. That means the element is going to decay, not growth. That means your future amount always going to be less than the initial. But they're telling you the half-life years is 1599. The initial quantity, which is the P, equal 14 grams. What about the amount after 1,000 years? It's a radioactive element. That means take really long time to decay. So let's check this information and how we're gonna find the amount after 1,000 years. So the first thing, in this case, they're not gonna tell you which formula are you going to use. But always you have to use the formula A equal P ERT. So this is always the growth and decay formula. In fact, here is not going to be R because it's a growth and decay. With some formulas, they can use K, which is the same thing like the rate, but now K is the element, which is the growth element or decay element. So I can use K, so you can see the difference, but it's exactly the same thing as like the R. But here in this formula is going to be the growth or decay. So now we already know our future amount is going to be half the initial. Our future is going to be half the initial. But if you look on this example, we have the initial 14. That means our future is going to be half the 14, which is equal 7. That means the future is 7. The initial is 14. E, K, we need to find the K. And the half time years, it's 1,599. So we need to find the K, which is the growth or decay rate. So our future is going to be 7 equal, the initial is 14. E, we need to find the K, and the time is 1,599. So now the next step, I'm going to divide both sides by 14. Cancel these. 7 divided by 14 is going to be half. Be careful. It's not 14 divided by 7. It's 7 divided by 14. So it's going to be E to the K, and here is the time, 1599. Now, next step, I'm going to take the length to the both sides, equal E, K, 1599. I forgot to put the ln here. So it's going to be ln to the EK 1599. Cancel these. So it's going to be ln to the 1/2 equal K 1599. Then the K, how are we going to find the K? By divide both sides by 1599, 1599. Cancel here. So K is going to be, we're going to divide ln to 0.5, which is the half, divide by 1599. The result is going to be, you see, it's the decay. So it's supposed to be negative 0.00043388. I'm going to take the whole number, so I'm not going to do any mistakes. So when it's decay, that means the future amount is going to be less than the initial. It goes down. Your K or R, it's up to you, is going to be negative. Now we're going to use the same information to find amount after 1,000 years. That means here is the amount P E K T. The amount after 1,000 years, that means the time equal 1,000. It's going to be the initial. We already have the initial is 14 grams. It's going to be the same amount. E negative, and here is the K, which is 0.000433,488 times the time is 10. Sorry, the time is 1,000. So we're going to plug in everything in the calculator. So A is going to be 14 E to the K, which is this number, times 100 close the parentheses. The result is going to be A is going to be equal 9.08 because we need to round the last 2 decimal places. That's mean 9.08. That's mean for this element, the initial amount is 14. The initial amount is 14. After 1,000 years, the amount is going to be 9.08. So that's what it's mean here. So we're going to type on this one here is 9 gram point 08. So for example 8, again, we're not going to care about the first part here. It's telling you is the sample of the element. And we have half-life years is 5,715. We need to find the initial quantity, and we have the amount after 1,000 years is a 3 gram. So the only information we have on this example, we have the time, which is 5,715. And we have half-life years, which is, we have the time, but it's half-life. That means our future amount is going to be half the initial. This is the second information. And we have the amount after, we have after 1,000 years, A equal 3 gram. This is for the second part. But from the first part, I have the future equal half the initial. So if I'm going to use the formula A equal P E K T, don't confuse yourself between K and R, it's the same thing. But K, we're using K when it's a growth and decay. So half the initial, so it's going to be half P equal P E K. That's what we need to find. And the time is 5715. Now cancel the K from the P from both sides. So we have half equal E to the K and 5715. Now next step, we're going to take the ln to the both sides. That's mean ln to the half equal ln E to the K 5715. Cancel the ln with the E. So it's going to be ln to the 1/2 equal K 5715. Then divide both sides by 5715. Cancel here. That's mean K is going to be equal. Again, this is only for the first part. So ln to the half, which is 0.5, you're going to divide it by 5715. So you see, it's also decay. That's why we get negative. It's negative 0.000121 2, always use the whole number, 86. This is our K, which is negative. That's why it's a decay, not a growth. Growth, that means it's positive. So now we have the K. After 1,000 years, our future amount is 3. So A, we need to find the initial. P, E, R, not R, let's do K. K, T. The future is going to be 3. We need to find the initial. And here is E. K is negative 0.00012186 times 1,000. Sorry. Okay. So now we're going to multiply these two numbers and take for the E. That's mean it's going to be E to the power, here is the K, times 1,000 years is going to be P times 0.88578059 equal 3. Then divide both sides by this number, 0.8857. On this one also by 0.8857, the whole number. So that's mean P is going to be equal 3 divided by this number. So P is going to be 3.39, because I'm going to round the number 39. So this is our initial amount. And after 1,000 years, the future is going to be 3. So it's going to be 3.39. That's it for this example. So with example 9, there's two parts. The number of Y hits a new website received each month can be modeled by this formula. You see there is a K here because we're not working with the interest. K is the growth and decay element. So here is the formula we're going to use. And they're telling you here's your Y equal is the same thing, 40, 20, e to the kt. That means if you notice here on this formula, here is the p. We already have it, the initial. Now let's see what they ask us. They're telling you where t represents the number of months the website has been operating. And the website's third month. Now here's the important thing. Third month. That means now our t is a 3 because the time goes by month. Where there were 11 hits. That means at that time, your future amount is 11,000 hits. Find the value of K. So now we're going to find the value of K. 11,000 hits. So I'm going to plug in the formula. 11,000 hits equal 40, 20, E, K, and the time is 3. So this is the first one. So we're going to divide now both sides by 40, 20. Cancel here. The left on this side, E, K times 3. Now 11,000 divided by 40, 20 is going to be 2.736. My advice when you're working with this example, write down the whole number. 2.736 3631 8408 408. So work with the whole number so you're not gonna do any mistakes. 08 equal E to the K times 3. Now next step, what you're gonna do, you're gonna take ln to the both sides. So ln to this number 2.73618 408 equal ln E K times 3. Cancel the ln with the E. So here is going to be ln 2.73618 408 equal K times 3. Last step, we need to find the K. So divide both sides by 3. That means K is going to be equal ln to this number divide by 3. It's going to be 0. You see, it's a positive. That means it's a growth. 5, 5, 3, 7, 7, 9. So this is the K. They didn't tell you to round to your answer to 4 decimal places. So 4 decimal places is going to be until this one. So here's our K, 3355. Because after the 5 is 3, so this is our value of K, 0.3355. Now, next step, use the value, which is the K, to the number of hits website will receive after 25 months. Now we need to find the future after how many, after t equal 24. So t equal 24 months. How many is going to be hits in the website? That's mean we need to find y equal 40, 20, e, and our k is 0.3355 times the time is 24. That means it's going to be 40, 20, e to the power 0.3355 times 24. It's going to be y equal 12, 6, 2, 3, 0, 76.71. Also, we're going to round to, round your answer to the nearest whole number. Whole number 71 is going to be 70. 71 here. So we're going to add one here. So it's going to be 77 here. So we're going to plug in 12, 6, 2, 3, 0, 7, 7. So that's what we're going to plug in here, because they ask you to round the whole number. So this is our result. That's mean this one is going to be equal 12, 6, 2, 3, 0, 7, 7. That's a whole number. So example 10, we have the number of bacteria increasing according to the law of exponential growth. After 2 hours, there are 50 bacteria. 50, okay. So in 2 hours, that means when time equal to our bacteria is going to be 50. I'm gonna put line here. The second part, they're telling you after 5 hours, there's 400 bacteria. So here is in 5 hours, when time equal 5, there is 400 bacteria. Now we need to find how many bacteria will be after 7 hours. So for the first part, I have only this information, and I can't use the 7 hours because I need to find how many bacteria is going to be after 7 hours. So I'm going to use the formula here, A equal P E K T. 50 bacteria is going to be the initial P. E, we don't have K, but we have the time equal to. Now I'm going to solve it for P. That means divide both sides by e to the k times 2, e to the k times 2. So cancel here from both sides. That means P is going to be equal 50 divided by e to the k times 2. So this is the first equations. That means my initial value is going to be 50 divided by e to the k times 2. Let's check the second part. We're going to do the same thing here. A equal P E K T. We have now the future is 400 bacteria equal P E. We don't have K, but we have the time equal 5. So now we're going to do the same thing. We're going to divide both sides by e to the k times 5, and here by e to the k times 5. So we're going to cancel these. That's mean p is going to be equal 400 over e to the k times 5. This is the second equation. That's mean my initial equal 400 divided by e to the k times 5. Check between equations 1 and equation 2. Both for the initial, and the initial is the same amount. That's mean p equal p. So in this case, 50 over e to the k times 2. Wait a minute, let's do it here on the side. We can say p equal p. That's mean 50 over e to the k times 2 equal 400 over e to the k times 5. Now I'm going to multiply both sides by the least common denominator, which is e to the k times e to the k times 2 and e to the k times 5. That's mean it's going to be 50 over e to the k times 2 times e to the k times 2 e to the k times 5 equal 400 over e to the k times 5 times e to the k times 2 e to the k times 5. Now here, you're going to cancel these, and you're going to cancel here. So the left from this side is going to be 50 e to the k times 5 equal 400 e to the k times 2. Let's check next step. What I'm going to do, I have number here. My goal is to find the value of k. So what I'm going to do here, I'm going to divide both sides by 50. So divide by 50, divide by 50. That's mean is going to be 400 divided by 50, which is equal 8. So divide this one by 50, divide this one by 50. Cancel here. So e to the k times 5 equal 8 e to the k times 2. Now, next step, x equal y, I'm going to take ln to the both sides. So let's take the ln here, ln to the e k times 5 equal ln to the 8 times e to the k times 2. On this side, you're just going to cancel it. But on the other side, you can't do that. Because ln to multiplication of two numbers, that means you're going to use the product rule here. So by using the product rule, on this side is going to be k times 5 equal ln to the 8 plus ln e k times 2. Now, after using the product rule, you're going to cancel the ln with the e. So the left from this side is going to be k times 5 equal ln to the 8 plus k times 2. Now minus k times 2 from both sides. Cancel these. So we're going to get k times 5 minus k times 2 equal ln 8. K times 5 is the same thing, 5k, because of multiplication, minus 2k equal ln to the 8. That means 3k equal ln to the 8. So divide both sides by 3. That means k is going to be equal ln 8, ln to the 8, divide by 3. So k is going to be 0.693147181. So this is the value of k. Now we need to find how much is going to be bacteria after 7 hours. That means A is going to be equal P, which is, we need to find the P. We don't have the P. So we can't find the A because we need to find the P. We have the K. I'm going to plug in K here or here to find the value of P. That means P is going to be equal 50 over E to the K, which is 0.69 times 2. That means our value, the initial value is going to be 50 divided by E to the power K times 2. P is going to be 12 point. Yeah, I can round it. They didn't say rounded. So 12.49, I'm going to say 50. I'm going to take 2 decimals. So this is the value of A. So, sorry, for P. Now they ask us to find how many bacteria is going to be after 7 hours. That means we're going to keep going. We're just going to say A equal P E K T. 7 hours, that means time equals 7, and we have the value of K, which is 0.693147181. And we have the value of P, which is going to use this information. So the bacteria is going to be after 7 hours is going to be 12.50 E. The K is 0.6931. Keep going. Times the time is 7. So here is going to be 12.50, not ln, E to the power K, which is this number, times 7 is going to be 1600. Because all the zeros here, 0, 0, 0, 0 until 5, so we can type 1600. That's it for this example. We're going to type here 1600. That's it for example 10. This is the hardest one. Let's keep going to example 11. So example 11 is going to be, for example 11, use the acidity model. We have pH equal. So here's our model, pH equal negative log to the H plus, where the acidity pH measure in the hydrogen, and they're telling you find the pH when H plus is 3.2 times 5 to the negative times 10 to the negative 5. That means pH is going to be negative log to the 3.2 times 10 to the negative 5. So we're just going to plug in everything here. So I'm going to say there's going to be negative log 3.2 times 10 to the power negative 5. Close the parentheses. And it's going to be 4.49. They ask you to round to 2 decimal places. So it's going to be 4.49. That's mean pH in this case is going to be 4.49. That's it for this example. So we're just going to type here 4.49. We got it right. For example 12, the last one, we're going to do the same thing, but the difference, for example 12, we're going to use the same formula, which is pH equal negative log to the H plus. We have the pH equals 6.3. We need to find the H. So we have the pH, which is 6.3 equal negative log to the H plus. Now we need to find the H. That's the tricky thing with this example. How are you going to find the H and there's a log? Do not say we're going to divide both sides by the log. You can't because log is a fraction. So the first thing you're going to divide by -1 because you have negative sign here. So divide this one by -1 and this one by -1. So it's going to be negative 6.3 equal log to the H plus. Now, next step, how are we going to solve this one? You remember that log by itself to x is the same thing log to the base 10 to the x, the common log. It's a log to the base 10. That means this one is going to be negative 6.3 equal log to the base 10 to the h plus. Now we're going to move this one to the other side. So h plus is going to be 10 to the negative 6.3. That means you're going to go ahead here and say 10 to the exponent negative 6.3. The result is going to be 0.0000501. So now we need to write down, because if you check the result, it's supposed to be number times 10. So I'm going to move the decimal. That means h plus is going to be 0.12345. 1, 2, 3, 4, 5, 6, and 5, 0, 1. So what I'm going to do, I'm going to move the decimals 1, 2, 3, 4, 5, 6, 7. So I'm going to say h plus is going to be 5 times 10 to the negative 7. That's it for this example. And here's the thing, I forgot the 0, 1, because they ask you to round to 2 decimal places. So 5.01. Because I moved the decimal until here. So the left is 0, 1. That's it for this section.